Welcome everyone, and thank you for attending today's live demonstration of OSIsoft's Pi system. My name is Tom Terpel, and our expert this morning is Dan McGovern, Systems Engineer at OSIsoft. Today's demonstration will take roughly 30 minutes, followed by 10 to 15 minutes of Q&A. I want to encourage everyone to submit any questions you may have via the Q&A option on the WebEx digital event platform. If we're not able to get to everyone's question, we will certainly follow up with a response after the demonstration. With that, I will now hand it off to Dan McGovern to get started with today's presentation. Dan, thank you for joining us.
Hey, thank you, Tom, and welcome everybody to today's presentation. We're going to talk a little bit about the Pi system in general, but I'm going to kick it off talking about OSIsoft and myself. I am a system engineer out in Philadelphia on the East Coast. So I imagine anyone else that's on the East Coast, welcome back from lunch, and for anyone else, good morning. So let me tell you a little bit about the company that I work for. So OSIsoft was founded in 1980 by our founder, Pat Kennedy, who was kind of just going around San Leandro out in California and thinking about the sort of, the sort of legwork and the sort of work that was going on in the industries, that he was kind of a part of and familiar with. So he would kind of think about the notepads and the pen and paper and jotting down, looking at a temperature sensor and the huddles and the teams that would have to go out and share this data and all the time that was lost. And he thought there has to be an easier way, and there's got to be a system that we can make that'll help people get informed of their data and become more business aware and data ready. If we flash forward to today, we have over 19,000 installations of Pi systems with over 4,000 customers all over the world. So OSIsoft has a global presence. We have 27 offices all across the globe with over 1,400 employees, and we have established ourselves as a world-class, customer support as a partner and a leader in data collection, analysis, distribution, and overall excellence. So we've always been proud to be pathfinders, and we really believe that when our customers succeed, we really provide them value when they succeed. So the Pi system itself is an excellent tool for really any piece of any sort of industry. And I imagine that everyone here today is from a vast variety of backgrounds. And just to give you kind of an example of where the Pi system can provide value and who is using it, you can see that over 1,000 of the world's leading power and utilities companies are utilizing Pi. We're in basically almost every oil and gas company. 37 of the 50 world's largest chemical and petrochemical companies are using Pi. So the reality is that everyone has recognized the importance of their data and the utility that it can provide them in making business decisions and really leveraging the information that they have available to them, and they want that to be done in a timely fashion in a way that's really going to drive success and help their employees understand the world that's going on around them and transform it with the data that's available to them. So the big thing about the Pi system, and you hear us use this word a lot, is that it's an infrastructure for real-time data and event enterprise information. So the concept is that we want to get actionable information into the hands of intelligent people to make informed decisions. So you have there's data everywhere, right? That's what everyone is realizing, that you can slap a sensor on anything and everything's out there running, doing whatever it needs to do. You have a million different things to worry about. And what Pi really wants to step in and do is be that one-stop shop that can come in and help you drive any sort of transformation, any sort of improvements that you could in any of these. We call these, I think, the general business impacts, whether they be safety and security, energy utilization, overall process efficiency, asset health, your quality of anything you're producing, and regulatory performance. So we want to really get in there and just cut out the all the busy work of really collecting your data, looking at your data, analyzing your data, distributing your data to the people that need to make those decisions, and just kind of make that all easy and simple, so you can get that quiet enjoyment of a Pi system that really just helps you transform your world with your data. here are some good examples of people that have made that, kind of step towards using data to make decisions and really understanding, the what's going on in their process in their world. You can see here that Petronas has reduced 5 unplanned shutdowns in a year, so kind of avoiding those downtimes, keeping that, that process flowing. The Columbia Pipeline Group has posted over $2.8 million in savings from from shutdowns and excursions and event prevention, kind of forecasting, how are things going, what's coming down the line, what can I expect, knowing what I know now, having tracked how things have run in the past. And there's 1,000 other examples just like these of just recovering what could be a lost product, with just-in-time analyses, anticipating future shutdowns or trending towards undesired kind of effects and things like that. So that's really the big picture of the PI system. Is right. We just want to help inform you so that you can run better and just have things kind of work out for the best. So here are a few of our kind of systems that we can tap into. The big thing about the PI system, we are the company that we are because we can kind of collect data from anything. No matter what you need to know, we're going to get it into PI, so that you have that one place, that one repository, one version of the truth. So you can see that the most common data sources are kind of highlighted or are emboldened here. So it's very common to talk to an OPC server, to an HTML document. Maybe you have a piece of machinery that dumps a flat file into a CSV, and we can just go in and parse that text. You have a Honeywell sensor, whatever it is. We have over 450 dedicated interfaces that talk to really any piece of equipment you have out in the field. We'll collect that data. We'll collect those timestamps. We'll get it all into one data stream, one flow into the PI server, and then combine all of that data so that you have one full PI server, and then we'll see how we can shape that up to really get that data in and format it in a way that any user that we have is gonna want it in whatever way they need. So say for instance we have an engineer that says, hey, there's a turbine that's not working. What's going on with this thing? We have a plant manager that says, hey, I need to make a report from the last 3 years, combining these 17 data sources, all this different information, to hand out to management. I have a technician that needs to know the moment something goes out of tune. I have a set point or an acceptable run limit, and whenever it crosses that limit, I need to be alerted immediately. And then maybe I have the COO up here, with an iPad, kind of checking things out and saying, how's the plant been running? What's the forecast of my productivity? I need to talk to investors. I need to have that information at my fingertips. So whoever your users are, the PI infrastructure is going to be that that kind of that bridge across the gap between where your data starts to where your users start. So we start off here on the far left-hand side with our assets, right? And I imagine the people that are here today come from a wide variety of backgrounds, but really the PI system infrastructure is very agnostic, and it's very it's the great thing about it is it's extremely configurable. So it's universal in concept and use. So no matter what it is, a mining truck, it's a wind turbine, it's an oil derrick, it's a bottling plant, it's a pill encapsulation press. We're going to have an interface or a PI connector that's going to go out, talk to these pieces of equipment, talk to these bits of your process that are going on, collect that data, find out the temperatures, the pressures, the rotation speeds, whatever it is, get that data and throw it into the PI server. So the PI server of today, we used to use this Onion, as we call it, the loving name for this cool graphic. Of today, the PI server of today really encompasses a series of technologies that you may only be familiar with the PI data archive at its heart, but we'll talk more about what all of these tools do that we've layered on top of the PI system as we go on. And then, using this PI server, we can go in and we can feed in data into visualization tools for our users out here, on the business side. So we have the PI Vision dashboard that we'll talk about more in the demonstration. There's the data link tool. We can go in and do some nice reporting. Manual logger for data entry. Process book is very similar to Vision, just a little bit different in design, a little older. If we need to go in and build some, programmatic tools, some custom Pi system access, or we have some, some customized needs, we can go in and we can write, we can script up programs, we can write our own custom visualization, custom dashboards using, using Pi system access development tools. We have what are called integrators that, as you might guess, integrate with other systems that you may be using for business intelligence. For Esri is an example of ArcGIS mapping. So if you have geospatial, technologies that you need to incorporate, or you need to, Pi to incorporate with, we have all these options for really piping your data out, from that, like I said, that one version of the truth, that one Pi server, and really getting it to wherever it needs to go to get processed and used however it needs to be. And then you can also share your data with Pi Cloud Connect, which is a service that connects you to maybe business excellence advisors, or consultants that have some sort of some knowledge to share about your process data, your information. So you can choose to share subsections or large pieces of data, however you need to. So the Pi server is really that universal one-stop shop for anything you need to do with data. So no matter what you need, no matter what you have, we're gonna kind of get in there and sort it out for you. So here's a quick example of the world as we're evolving with, right? So maybe we have you're probably familiar with having a plan or a site where we have all these different locations of data, all these different kind of equipment equipment types and repositories of information. Maybe we have some SCADA systems, we have some instrumentation, some PLCs out there. We have an asset reliability data warehouse. Maybe we have a few different Excel spreadsheets that people write data to. There's an ERP system, a LIMS system. Maybe this is all separated and scattered. Maybe we've got some database links here. This calls that. This thing is linked to this, and we have all these silos of data, all these islands of information that are kind of loosely linked together, and you really need to know who to talk to about, to go and get access to this information. And it's a hunt, right? It's a challenge to get in there and really find what you need and build those reports. And it's a harrowing experience sometimes, to work without Pi and to really get a handle on what's going on. It might not be so harrowing, but it's certainly going to be time consuming, right? What the Pi server does is we make it a whole lot easier, where we have that one server, we throw in the interfaces, we install the connections that we need to collect that data, and then we'll be able to enhance it and deliver it all in one place, so that people can just come use whatever tool they need to build the reports the way they like them, the way they need the information presented to them. But also we can pipe that data back out to the systems, the big data analytics, the LIMS, laboratory type testing, ERP systems, whatever it may be. So whether it's people or systems or users or analytical tools, anything like that, the Pi server is going to kind of seat right in there and take away a lot of that legwork and a lot of that those headaches of tracking all of that all of that information from beginning to end. So the big thing for data collection is that, like I mentioned, there's interfaces and collectors. Interfaces are our original kind of, they just go in there. they're pretty much all Windows based. They run and they collect events, just timestamps and values from any sensor you have in the field, and we put it into what's called a Pi tag in the Pi data archive. And these streams of data are just informing you as to what's currently going on with your process data. The next kind of class of Pi data collection is Pi connectors. That's kind of a new school of data collection that is contextually aware of what kind of asset it's talking to, what the data is, what the descriptions are, maybe what the units are, and that that can run largely on Windows and Linux. So these are being actively developed. Pi interfaces are also developed and maintained, but connectors are kind of moving towards a world of more contextualized data collection. And then one of the things we've an exciting kind of change is we have this new software called the OMF, the OSIsoft message format, which allows a person to write their own data collection, protocol that can go out and basically run on anything and go and collect data as needed. So the OM PI interfaces write to the PI data archive. Connectors can write to the PI data archive and asset framework, and OMF are like connectors that are configurable and customizable, and you can just build from the ground up. So you guys might have only ever heard of interfaces, which is still how probably most of the data gets collected out there right now, just kind of streaming in sensor data into tags. But for this talk, we're going to be basically talking a lot about how that second layer that I just mentioned, the asset framework, can go in and really help you shape that data and contextualize it and deliver it to your users in a much more usable format than just sensor to sensor, tag to tag data. So how do we deliver that data? So we're going to talk today about PI Vision in our demonstration. That's our flagship visualization tool. That's the one that we really want customers when they what's their first point of contact with the PI system is going to be a PI Vision dashboard, a PI Vision set of displays that presents their data. It can be built collaboratively, easily shared, edited and constructed with a very simple workflow. It's usable on any device. You don't have to install anything. It's a web-based platform that uses HTML5 to shape up your data and present you with a very modern, very fast, and useful displays. And it's extensible, so you can kind of build on top of that. Data Link is an add-in from Microsoft Excel, so it'll let you go in and build a report similar to what we're looking at here. It's good for data analysis, calculations, event tracking and analysis for reason code analysis, for tracking how often things happen, just doing overall reports, historical type reporting, and it's kind of the people who are very adept at Excel kind of usually get a lot out of that. So you can build very, very clever automated reports that are flexible, that present PI data in a very living and structured format in an Excel report. And then again, for integrating data outside of the out-of-the-box PI visualization tools, there's the Esri integrator that lets you see your real-time data on a map out in the Esri ArcGIS system. You can integrate with learning models, what's it called, machine learning, like Microsoft Azure or Hadoop. You can pipe out to business Power BI, Business Analytics, TIBCO Spotfire. You can shape up your data and use the categories and the templatizations and the correlations that you've started to lay out in an asset framework that really provides contextualization to your data and start to dig into why are things happening, how are things happening, what's the big picture here. Okay, so I've mentioned the asset framework a couple of times. Let's kind of dive in here a little bit and talk about what exactly it is and what exactly it does. So the big picture of the asset framework is you have, like I said, all this data out there. Maybe you can start off, up close, kind of looking at what's the temperature here. Your kind of your macro factors, your simple key performance indicators. But at the end of the day, you really don't want to be working, entirely focused on one data stream or another data stream, because there's just entirely too much data to really focus on any one kind of tag or hard code yourself into talking about just one sensor or another sensor. We really want to seek to make it easy to rapidly deploy new equipment or different sites, or be consistent in our analytics. Say, hey, for any mine truck that I have, it'd be good to track the overall fuel economy, given the elevation and given the temperature outside and given the haul load. So we're not really talking about just one piece of equipment or one piece of data. We're talking about an asset and a general concept of how we track success and efficiency. And we want to have that consistency of logic between each piece of equipment that we're working with, and want to make it easy to maintain and develop and build upon those. So it really lets us centralize that logic, centralize that knowledge, so that not only the users that have built that data can kind of gain value from it, but that anyone can kind of approach your situation and kind of know a little bit more about things outside of their immediate scope of their their favorite 5 or 6 tags they always work with, right? So really, what the asset framework does is it provides a meaningful structure to your data in common terms and relationships that lay out a logical flow and a sort of navigational, correlational structure of your data. So the kind of the concept here that I always come back to is your data is like information, and it's good to have and it's good to store, but you could be the smartest person in the world, you could be an absolute genius, but if you can't, if you're not able to communicate the things that you've learned and the knowledge that you have to anyone, you're never really going to be able to transform the world that you're in. So the asset framework seeks to take that data and kind of mold it into a useful shape that is informational, that is that is transformational. It takes that data and builds it into a form that people can really go in and simply enjoy and use and build out the displays from and build the reports from, and the legwork, the onus of maintaining that data and understanding that data is not really on the user so much, because it's more conversational. So you can see here that we have our compressor discharge data, our exhaust gas pressure. You don't really have to know a lot about the underpinnings of where that data is coming from, or the strange prefixes and suffixes of all the data. You just know what that sensor is and at site what it is. So let's say, for instance, we have a set of pumps or a set of pieces of equipment here. Over here in our cracking process. So let's pretend. We're going to pretend in this presentation that we work for a few different companies, so just come with me on this. So the great thing about the asset framework is it lets us, really contextualize our data outside of just, what is the pressure on at this time. It really lets us describe our pieces of equipment completely, so that we can know, okay, what is the time series data, but here are all the time series, data associated with this piece of equipment. Here's the flow, here's the pressure, here's the vibration, and we can put things in that we would never store in a tag, like the name of the asset, the model, the manufacturer, the last time it was installed or maintained. We can look up data from external tables or external data sources, like performance curves that are maybe like ideal operating conditions. Here's what we would expect for the for the situation given the current time series data. Design documents, best operating procedures, links to information that again kind of build a complete picture of our process, of our equipment, that don't necessarily fit the mold of a time series data point. We can build analyses that, again, building an analysis for one piece of equipment, maybe it would make sense to go in and track that same sort of key performance indicator, that efficiency for every other similar piece of equipment. And we don't want to have to copy and paste. We can go in and have an easy, what we call a template, that says, hey, here's a class. You're now building out kind of, you're taking your process knowledge and handing and building it into Pi and saying, hey, here are the types of equipment I have, here are how many pieces I have, here's what they are. We can track events like downtime, startups, failures, excursions, ideal runs, runs in general, how much longer did this take, things like that. And then events and notifications are literally the same thing in the modern Pi system. Notifications are just events that you get alerted to. So again, they could be like high-speed notifications, just critical events that you need to know just in time. If there's your pump amperage is ramping up, you want to know when it goes above a certain critical level. The pressure is bottoming out, anything like that. You can receive a text message or an email, and we'll see what the events look like later on in the visualization demo. And then, here's just a quick example of where this is a tire press that we're tracking overall equipment effectiveness for. You can see here that the logic is simple to write. We can go in and we can calculate our availability, our quality, our performance data, depending on ratios basically how often a piece of equipment is running versus how often it's scheduled to run, how well are we producing product versus how many overall pieces of product we've produced, and are we operating? Are we hitting the performance target that we're rated for? And all of these things can be combined quite easily into an overall asset score. And we can go in and we can roll these things up and we can say, hey, here's my equipment that's having trouble. Here's the equipment that's underperforming. So we can have these sort of condition-based maintenance, asset-based, scored information. We can kind of write that logic once and apply it to any piece of equipment that would be beholden to those sorts of logical checks. And then here's an example of event frame generation. So again, we could use raw data, we could calculate efficiencies, we could calculate alarm type tags, and we can go in and say, for instance, if we're using a fuel flow rate and a output flow to calculate some sort of efficiency. It's a very complicated example we have here where we're dividing one by the other and multiplying by pi the number. And we can go in here and we can say, hey, I need to know whenever my efficiency is below some sort of nominal limit. And just go ahead and track an event frame whenever this happens. And you can go ahead and end the event frame once this happens and some sort of other goal is achieved and things are back on track. So the concept of event frames is really an extension of the asset framework model where the asset framework tells you what to look at, and the event frames tell you when to look. So they're basically just chapters in data that are important to you that you can go in, track how long they went on for, what sort of what particular individual pieces of equipment are actually having these events more often than the other pieces of equipment. Why are they happening? So it's again taking that step back away from just being up close, looking at a dial and saying, oh, this thing is too hot. Where now we're talking about equipment over equipment. We're talking about our assets as a whole, as a concept, as opposed to just here's this this one sensor right here. So event frames can be generated by events by analytics that we write ourselves. We can trigger from attribute data. We can trigger from incoming data. We can have an interface that has set points, that has active tags that tells us here's when event started, here's an event ended. It's called the event frames generator interface. And then we can have there's external systems that can also hand over basically information that tells us hey, this thing was detected, started here and ended here. So there's BES and MES systems that can go in and inform us as to which pieces of equipment are having events and what they are. So with all that being said, I'm going to go ahead and jump into the demo. So let me go ahead and show you guys some of what I'm talking about and how it would work. So here's an example of a Pi Vision display. This is actually from the San Leandro Tech Campus, our headquarters out in California. And kind of just for a general walkthrough of Pi Vision, I think this is a pretty good example where we basically just have sensors all throughout the San Leandro Tech Campus, our building out there, that just measure humidity, temperature, airflow, things like that, just so we can have a good picture of what's going on, with the occupancy inside the building and the energy usage and things like that. So kind of the first asset we're going to talk about here is just, our headquarters are just as a building itself. So you can see that, the kind of the main area here, just has, a landing page with some simple information on it, some good aggregate data. And overall, all of these examples are designed with a kind of a structured approach that a lot of customers have found, value in, where you can have link displays that maybe go from general to specific, or general to more granular. So you can see here we have some high-tech, really cool futuristic type glass that it's called view glass, and we can just see whether or not it's dirty or clean, or what the I guess the overall luminosity coming through in here. Maybe we have some lux meters on the inside to say whether or not the glass is clean or not. We have just the overall average energy usage this month, and it's kind of trending as a year over year to show whether or not this this building has been slowly ramping up or using the same amount of energy. And we can see over here we have these alarms that are telling us about our HVAC system and are there any things going on? So we could navigate over. We have floor 3 here. We could navigate in and check out the floor map for floor 3 and see what's the kind of situation going on for the HVAC system, the heating and cooling on floor 3. And I can see here that I have kind of immediate information here just from the the coloring and the shading and the layout of the data here to know that, okay, so the west side of the building here is mainly on cooling. I can see that these air handlers, 3-07, 3-04, 3-06 are in charge of of this area. I can see that the thermostats are positioned around. There are actual temperature sensors are positioned in these strategic locations, and I can kind of get that instant information as to what exactly is going on, the situational awareness to know what is happening in this building on this particular floor. Over here on the right hand side, we can kind of get a table of data as to what are the set points on these thermostats, what's the current ambient temperature in the room, is it cooling or is it heating? And then down here on the right, we have, these are actually event frames that are telling us that the room has been designated to a temperature set point that is unattainable, or at least it appears to have been unattainable because it's been trying to to reach that temperature for more than a set period of time. So we call these these are the variable air volume controller alarms. I could go in, I could double click and see, okay, hey, I see that 3-04 over here in the cooling area has been set to a temperature that it cannot attain. It's been going on for too long. And I go and I can see, okay, what's the story with this event? So if I click onto this event, it'll bring me into the details view of an event frame. An event frame, like I said, is just basically a chapter in time that's interesting to us. You can see over here it starts at the 0th minute, and it's telling us how long it's been going on. So this is a event frame that's currently in progress, and it's been going on since about a little after noon East Coast time. And I can see that the room temperature, currently it is occupied. Maybe we only have event frames to track when there's problems with our heating and cooling. We don't really care about it if it's occupied or not. We know that it doesn't actually run. The set point doesn't matter if there's no one inside. We can see that the current set point is set to 74. But the room temperature is 71, and maybe we know that maybe there's a window open. We can go in and we can check on that room. We can provide like a reason code to say that maybe the window tint was supposed to engage with the smart glass, and the opacity isn't set correctly, or there's a meeting going on in that room, and there's currently 700 people. 700 was an insane choice for this example. There's 70 people. That's still way too high. Let's say there's 17 people. That's good in this room, and so the body heat of the participants in this meeting, or they're doing yoga in there, and it's hot yoga. So they want it to be hot, but someone forgot to change the thermostat. You guys get it. So any sort of reason that we would want to subscribe here, we can do this retroactively. We can go in and we can say, hey, let me look at these events. I can go in and I compare these to other events. But this is actually the same display you would get if you received a text message or an email of a notification that contained a link to an event frame that describes the notification and tells you, hey, this thing's going on. So you can go in and you can basically take these actions and say, oh, okay, I'll go and look into it. Maybe I'll go and check. Has the set point changed? No, it's been 74 all this time. Maybe just check the general room temperature. It has been going up, and maybe it'll clear out. And I can go in. I can see, I can trend and untrend things from the event frame itself that I've captured as a measurement on that time frame. But I can also just go and see what's going on just generally in terms of data, of the surrounding, the piece of equipment that's having the event, that's delivering, the airflow and everything like that. So that's a good example here of kind of just drilling in, finding out information here. There's we have just links basically just built out to navigate through the rest of the high vision displays for these guys. So I could go in and I could take a look at maybe some key performance indicator data, and I could go to the building KPI overview and see, hey, what's the overall load? We saw this kind of same information was on the main screen, but maybe I want to know, like, hey, I could go and check out that floor. and maybe, I manage this in Philadelphia and it's, 80 degrees out here, and I'm like, well, why is the temperature set to be, 75 or whatever? And I can see now I'm like, why are they heating out there? Because maybe it is a little chilly in San Leandro right now for whatever reason. It's, it's 63 degrees outside. I don't know how true that is. I guess it is. And I could say, oh, okay, I guess that makes sense. So it's a little, chilly over there. Maybe they want to heat it up a little bit in some rooms. People like it a little warmer. So I could go in. I could see, all the rooms that are, I can go in and get a kind of a heating and cooling summary down here, and I could say, just kind of jumping to that one overall view. Maybe we're scraping data from a from a weather service, from a nearby weather station, from the web. I can go in and I can see, okay, which pieces of equipment are heating, which pieces of equipment are cooling. What's the general kind of delta from the outside air temperature for the last day or for the last 8 hours or so, and I can see how, kind of how things match up and how people are reacting to the current temperature, and how acceptable that is, and what our overall energy usage is as a function of that temperature, to really gauge, okay, like, this makes sense. There's no areas where the big thing that I could kind of discover here is if one area is both heating and cooling, and no one's really complaining because they kind of canceling each other out, but we're using tons of energy to kind of just spinning our wheels just for no good reason here. So you can see that all this, navigation is pretty straightforward. The big thing being that if I wanted to go in and say, hey, let me check out another floor here, when I click on floor 4, it knows that floor 4 is, is linked to this display, and to show me the data from floor 4 because of, of the context that I get from having, the floor itself built as an asset, as a virtualized, piece of kind of equipment of a subset of my system, as a piece of my system. And I can go in here and say, hey, tell me about this piece of equipment here for this particular HVAC component, and I could go in and I could see, maybe if I look at, let's see here, one of these guys over here, a variable air volume, kind of, like I said, kind of drilling down from the general to the specific, and see, okay, here's a diagram of exactly what this piece of equipment is doing, what's going on inside of it, what's the room temperature that it's in, with the occupied set point, and I can get a much more granular view if I wanted to go in and say, hey, I do see that there is an event going on in this room. I want to check the temperature. I want to check the airflow. Maybe I know that I should be delivering cold air. Maybe it should be dilated to 50% open or something like that. But I can see that maybe there's a jam here. It's only 23% open. And you can see that the scaling on the colors and the information it's very easy to kind of detect those anomalies and really get a instantaneous a complete picture of what's going on. So let's walk away from the San Leandro Tech Campus just for now. We can jump over. I'll show you guys just a couple more screens that are kind of fun to look at. We can think about the Petrolux Refining Company that's got sites all over the U.S. here, and here's another great example of just kind of coming from the general to the specific. We can have this kind of bird's eye view for maybe this is the only display that our management ever looks at. They just want to know what's our current processing rate, what's our utilization of our equipment, have we had any environmental alerts or reportable problems, and have there been any safety violations. We could go in and we could drill down. Maybe I want to look at the Houston area and see overall there, in the past week or so, have there been any safety violations? Have there been any environmental violations? What's our feed rate and our daily target? Are we meeting our demand? What's the overall yield? And we can have these, a lot of people like to make, sensors that are just, these will be dynamically changing, between red, yellow, green, whatever it is, to represent asset health or represent, overall success, or whether or not something is an alarm or things like that. We can see our our costs and expenses, how much we're generating, how much we're making here. There's some granular analyses going on to calculate revenue loss and gain as a function of changes in operations or quality of our product or pricing. We can compare site over site to see, is there any gypsum efficiencies? Is any one site performing better than any other? So all these dashboards are completely configurable. You can see that, we have tables, trends, XY plots, symbols that we can draw on. We can have what we call multi-state color changing. That's going to be contextualized in color by the status or the value of any tag or data attribute that we've pulled into the asset framework. We can go in here and see our equipment status for this refinery. We can check on this individual pump by navigating in and seeing a pump detailed view. So again, here we'll have kind of the general view of the pump here. We'll have vibrational data trended up here. We have event frames for high vibration events, for bearing temperature events, and cavitation events here. We have a pump performance curve. Maybe again, this is externalized data that we have this this pre-calculated manufacturer specific. Here's how all the pumps should perform given this PSI and this gallons per minute flow, and here's what we would expect. So we can measure up and see is this sort of trending down maybe over the last 7 days? Here are our data points. Are things fitting on the curve? Are we nearing the kind of a downturn? Does this do we anticipate that the lifetime of this pump is nearing an end, or that needs to be maintained with some sort of from some sort of upkeep? So we can learn a lot just by looking at this data. And one of the big sound bites that I learned from one of the guys that kind of taught me everything I know at OSIsoft is that the big picture of asset framework is that it's reducing the risk of curiosity with with how easy it is to go in and build these displays and reuse these displays, because I know that I could be thinking about pump 2 right here and saying, okay, pump 2 seems all right, but the nice thing is that I know that pump 2 is a pump, and I can go in and say, hey, tell me about pump 3 as well, and I can change my data over and basically just redirect to looking at the same display for a different piece of equipment. So I can go in and basically just select from a list of any other similar piece of equipment and have one display built that you can navigate on and learn more about, and I can drag into I can drill into those events. But at the same time, you can see that now I'm on Houston pump 3, and all the data has changed and everything's updated in the context of that piece of equipment. And I can go in and I can say, okay, let me check a different site, and I'll check. I'm not exactly sure where MAR is, actually, to be perfectly honest, but maybe this is, say, it's Marseille in France, and this is another pump over there. And we can go in and we can find out more about this particular pump. So we have basically that contextualized information that we can go in and know what's going on. And I see that, hey, maybe the vibration for this this pump is kind of out of control, and I can go and check out a troubleshooting checklist that we have linked externally to some data that I can go in, and if I'm an operator, I can say, oh, this pump isn't really working out great, and it's protocol that I need to go in and fill out this checklist and go in and check, is this on, is this not, fill this all in and submit this. So we can link out to any sort of procedures and things like that we have. Okay, and then just one quick last one. Again, using that same sort of concept of having your assets built out and categorized as the sort of assets they are, and tracking information. We have a wind farm here that we have, Big Buffalo, Black Mesa, and Black Wolf. We can go in, we can see the sort of revenue we have. Again, just kind of a high level overview. We can drill into Black Mesa maybe and see what's kind of going on on the ground at Black Mesa. How are our turbines operating? We have 3 in normal operation. Maybe we flag them if they're in a low wind spot, or if they've been currently curtailed, or they've shut down for whatever reason. I can go and I can check. Oh, maybe this turbine is underperforming, and I can drill into it and see an in-depth view of its power curve. Is it matching up with it? What's the current active power that it's generating, and what's the expected power given the wind speed that it's subject to currently, and is everything going well here? And if it's not, I can go in and say, oh, maybe I'll check out the schematic and see if the blades are set correctly, see if the bearing temperatures are all right. If anything's running too hot, I can get an interior view. I don't know if it's a word, but an interior view of the the housing of this piece of equipment, and check out the kind of all the data. And again, this is a little more tabular here, but you can imagine that any piece of equipment you have, you could build a similar display. You can kind of scale it, build it however you like it, and it's easy to maintain because it's contextualized by the the type of equipment that it is. So I can again switch here and say maybe this is turbine 7. Let me take a look at turbine 3, and I can click on this guy. And now it's kind of hard to detect, but now we're over at turbine 3 over here. I can go back to turbine 6. And it's all the same display, just different, it'll be different data points, well, not different, really, it'll still, every turbine has temperatures and everything, but they obviously have different tags, different, maybe potentially different set points, different serial numbers, informing how the display updates and everything like that. So again, just to kind of level things off, having your data is great, but you really always have to ask yourself, what has it done for you lately? And the asset framework really serves to take that data, shape it up, and present it in a way that's easy to build with, easy to understand, easy to use, so that the people at your company, their lives are a lot easier and their jobs are a lot more focused and driven by the data that will help them, transform the operations that they're in charge of. So with that, I think I'll come back and check in with Tom.
Thank you, Dan. That was great. And we really appreciate your participation with the demonstration. All right, folks, at this time, we're going to be taking questions from our audience. Once again, please use the Q&A option to the right on your WebEx interface, and we'll answer your questions as they arrive. If you happen to have changed your view to full screen, the Q&A option may now be located at the bottom, so keep an eye out for that. And we already have a couple questions already in, Dan. Our first question, for the pharma industry, it's important to comply with data integrity, and that includes assuring that no data is overwritten in a database. Has the PI system have a problem with rewriting the data in case of a time correction to the past?
Right. So the thing is, the PI system will let you update data, but what we do is we have actually, whenever we store an event, which is we describe an event as a timestamp and a value, we actually store 3 additional bits of information called the quality, whether or not it's been overwritten or updated. And there's one more bit that I'm trying to remember. Maybe just quality and whether or not it's updated. But basically, we will flag any events that have been overridden. And what we do, pharmaceutical companies, this is very common. Pretty much every pharmaceutical company we work with does this. Is we have what's called the PI audit tool, which basically is a system that runs and just tracks any change to any sort of tag configuration, any sort of tag data change, so that there is ever any sort of recalculated data, updated, data, maybe backfilling of data that was lost, that was not immediately available or was marked as, as bad data, but it was recovered from somewhere. All that visibility is maintained, so that with any sort of, reporting, you could always trace back and say, okay, here's exactly what happened here. So I would urge you to just look up the PI audit viewer and just PI auditing tools. But yeah, we can definitely provide more information on that.
Great, thank you, Dan. I also want to let folks know that we're going to be having a webinar specifically on data integrity at the end of June. So stay tuned for that, and I'll be sure to have a follow-up link in our emails moving forward after this demonstration. Dan, our next question. Is the PI system more of a data acquisition system and not a SCADA system or system control and data acquisition? One viewer noticed that there were no parameters changed in the process of your demo.
Yes, yes, that is one thing that is very crucial to recognize is that the Pi system we are not a control system. We don't set any. We never really want to be making any changes on your equipment. We never want to be pushing data back. Basically, we seek to be ideally read only. Take in the data from your process. Keep it safe. Analyze it as needed, provide it as needed, but not really control. So yeah, we are not a SCADA company.
Thanks, Dan. Our next question: is it possible to click on an event from the events table and have it place a bar or marker for that instance in time on the process measurements?
So you can. So one thing I didn't show, if you do click on onto trends, it'll drop a line in here and tell you, hey, here's the value of all of these sensors at this particular time. And I can click and drag this timestamp, and it'll tell you about those. So if you were concerned about, hey, what was going on at this particular time, you can click and drag in and zoom in here, and you can drop a line on here to find out what was the exact value at this time. But can you just read that question one more time? I think it was specifically more about the event frames themselves they were asking about.
Certainly. So our audience member asked, is it possible to click on an event from the events table and have it place a bar or marker for that instance in time on the process measurement?
I see. So you're thinking, so you have like trends up on the display. What you could do is, I believe if you go in, there is a way to go in and we can have events over here. So let me just go in and just grab maybe one of these guys. You can train your display to adhere to the time frame of an event. So if I go over here and I say, hey, tell me if there are any events for this piece of equipment, and you know what? Let me just see if I can just find some for any. But if I did have some over here, I could right click on some and say, basically set the time frame of this current display, and you can see down here at the bottom left and bottom right, these timestamps are actually configurable, and it would train my display to be focused in on the actual from start to end of that particular event. I don't believe that's a feature on the event frame table, but you can dynamically go in and say, hey, tell me what was going on, show me the context of this display or any display over the course of that event. So that's something you could do.
Thanks, Dan. Our next question: are there any future prediction features like failure prediction?
So out of the box, the Pi system does not really build analyses for you. So kind of that one slide we showed you here for actually building out kind of asset scoring and things like that. You could go in and you could either build out your own custom kind of analysis to have sort of predictions and things like that. We have partners that do business intelligence, data analytics tools that can go in and do this multivariate calculus to understand the correlations of your data. What the expected pressure would be, given the ambient temperature and the current flow rate and things like that. And then you could ultimately build out whatever sort of analyses you would need and run them with analyses or with customized tools. So that all does exist. But there's nothing out of the box that you can really just kind of click in and say, hey, tell me what's going to happen tomorrow. If we could do that, we would be a very rich company, I imagine. But we certainly provide you the tools that'll help you do that.
Excellent. Thanks, Dan. Our next question: I'm interested to know if Pi Vision has predictive maintenance capability organically using machine learning algorithms. If yes, how does that work?
So we don't. So like I said, we don't have an out-of-the-box solution for that. But what you could do is you could use the integrators and integrate that out into Microsoft Azure. I know that's a great platform. It's a very obviously it still takes a good amount of data science and know-how to kind of tease out those correlations and build those models. But we can use we can use existing tools to take Pi data, shape it, cleanse it, filter out outliers, filter out, noise and things like that, and kind of, build those linkages and have that machine learning chew on that data and give us, a more bigger picture, better answer than just, any sort of simple linear regressions and guesses that we could make. So that's definitely something we could do. And there's a ton of information on that. So it's definitely it's an exciting topic that people are really starting to dive into.
Great, thank you, Dan. Our next question is: the Pi system able to admit manual comment introduction as added data?
To omit?
No, to admit, I think import, manual comments as added data.
Okay, so we can. So there is a tool called Pi Manual Logger that will let you, and it doesn't care. It doesn't have to be a a numerical value. A manual logger can take in strings, take in operator comments. As real Pi tag values. So you could set up a manual logger, input to have any sort of data that you would need like that. We are hopefully in future releases of Pi Vision for the coming releases, not this immediately release. We're looking on kind of incorporating that as well into Pi Vision in the future, hopefully. And you might have seen, and right now we have, the one thing we can do is we can go and we can provide reason codes onto events. So any way you need to supply data into your system, there's definitely a way to do it. And for manual data entry, currently the best way to do that is a thing called Pi Manual Logger, where you can basically, and there's a web interface for that, which I haven't showed today, that again, you can go in and you could submit that data in there.
Great, thank you, Dan. Folks, we're running out of time, so we're just going to take one more question. If we were unable to get to your question during today's demonstration, we will follow up via email following today. All right, Dan, our next question. Are there templates available for renewable facilities so it's easy to upload points or inverter points into a common format? This person says they're dealing with multiple vendors that have various forms of points that are not listed in a standard format.
Yes, that is a common problem. I actually, one of the jobs that I work on is Pi System Jumpstarts, where we kind of get people aligned so that they can start using their tags with the asset framework and kind of fitting them in to the attribute data, to the descriptions of the categories and the formats that are going to be useful to build visualization tools with and reports with. And we actually do have a great kind of run through. I think it's called, getting started with, there's tips and tricks with building out assets and attribute data. One of the things we can do is we can build tables of data. We can kind of just submit in AF and just say, okay, here's where my tags are. I can either grab them from existing displays or, existing worksheets, wherever they are. And then we can kind of, query those tables to fill in the blanks and fill in our attribute data. There's ways that we can use existing naming parameters to dynamically build out the links to our attributes, to build out, to inform those simple, easily communicable names that asset data is described with. And we actually we do kind of have templates that you can kind of get some inspiration from. On our tech support website, we have things that are called AF example kits. So we have them, they're industry specific, and you can go on, you can see kind of, how things are laid out, what sort of analyses, what sort of elements, that we've built. But that's definitely something that it's not uncommon to find difficulty in navigating, kind of taking those tags and building them up into something that that can be more than just a flat kind of ocean of data, and to kind of extract that information from it. But yeah, so if you can't find that, definitely reach out to tech support, or we can send out information after this. But yes.
Thanks, Dan. Well, folks, we've run out of time, and I'd like to thank everyone for attending today's demonstration. If you do happen to have additional questions following our session this morning or this afternoon, please feel free to reach out to us from one of the follow-up emails we'll be sending out after the webinar. Once again, thank you for attending today's demonstration. Hope you have a wonderful rest of your day. And Dan, thank you again for leading today's session.
No, thank you guys. Everyone, have a great day, everyone.